Precalculus review of algebra prior to calculus part 6, equations of lines and coordinate geometry. This series, in which this video lesson is part 6, takes the effort of Canadian math teacher Jeremy Clausen. I invite you to watch his video lessons. I'm going to bring my own slant to these exercises today. Okay, this first set is going to be finding the slope and y-intercept of the following. We have x plus 3y equals 0. So to find the slope and y-intercept, a good way to do that is to find what's called the slope-intercept form, which is the form y equals mx plus b. And for this, if we solve for y, so we have 3y equals negative x, and then we divide by 3, so y is equal to negative 1/3 x, and we don't have any constant attached here, so for this we have y equals mx plus b, the b here being 0. So for this particular equation line, you have the slope is equal to negative 1/3, and the y-intercept, which is b, is equal to 0. Okay, let's go on to the next one. B, we have 3x minus 4y equals 12. Again, if we solve for y and get in slope-intercept form, we can subtract 3x from both sides of this equation. So we have negative 4y equals negative 3x plus 12, and we divide by negative 4. What we're going to get is y equals 3/4 x minus 3. So our slope is going to be 3/4, and our y-intercept b is going to be equal to negative 3. Alternatively, for y-intercept, you could say y-intercept is the coordinate pair 0, negative 3, or you could say y-intercept of negative 3. So different ways of articulating the answers here. Next, C, we have y equals 5, and so if we put this equation in slope-intercept form, we're going to have y equals, we do not have a coefficient with x here, so we're going to have 0x plus 5, and so in this instance our slope is going to be equal to 0, and our y-intercept is going to be equal to 5, or we could say the coordinate pair 0, 5, or you could say b in the convention of slope-intercept form language is equal to 5. So different ways of looking at this. Okay, next, D, we have x equals 4. Now what does this mean here? Okay, what this means is this. That means that x is 4 everywhere. So if we have an xy coordinate plane, okay, we have x equals 4. And so what that's going to look like is this. We're going to have a vertical line whose equation is x equals 4. So what is the slope? Well, this x equals 4 is not a function. A vertical line is not a function. So we say m, we don't say m equals, we say m, or the slope, is undefined. Okay, and there is no y-intercept being parallel to the y-axis. Y-intercept. Okay, so that's that one. Next, we have the set here. Find the equation of the line with the following conditions. We have the line through this coordinate pair 1, 7 with a slope of 2/3. Now for this, the recommendation is to use the point slope form, and that point slope form is y minus y1 equals m times quantity x minus x1. And so for this, we can say in this coordinate pair 1, 7, we say 1 is our x1 and 7 is our y1, and our m, of course, m is equal to 2/3. So our equation in point slope form, and I'm going to just write this down, point slope that's going to be y minus, and y1 is 7, equals 2/3 times quantity x minus x1, which is 1. So this will be our equation of line with following conditions. Now, next, B through 2, 1 and 1, 6. So we're given two coordinate pairs. So you can find what we need to use point slope form is a point, and we have 2 points, and a slope. So we can use the equation for a line. We have m, our equation for slope, which is going to be m equals the change in y over the change in x. So we can go ahead and call this one here 1, 6. We can call this x2, y2, and this point 2, 1 we can call x1, y1. And so just plugging in here, we can say 6 minus 1 over 1 minus 2. So we're going to get is 5 over -1 equals -5. So -5 is our slope here. And so we can use either of these points in point slope form. So we can write this as y minus 1 equals -5 times quantity x minus 2, and alternatively we could use the other point. If we use 1, 6, we would write that as y minus 6 is equal to -5 times quantity x minus 1. And if we simplify these out and solve for y, you'll be able to see that these are really the same equation. Okay. All right. Let's go on to C. We have an x-intercept of 1 and a y-intercept of -3. Now, I don't know how, there are different ways to do this. You can go ahead and look at these graphically. You can say, okay, well, our x-intercept is 1 and our y-intercept is -3. So we have that, and so you could see that we have up 3 over 1 So we should have a slope of 3. But one way to do this is you can use these as coordinate pairs. The x-intercept is going to be the coordinate pair 1, 0, and the y-intercept is the coordinate pair 0, -3. And so you can just say that m is going to be equal to y2, which I'm going to let -3, minus y1 over x2, which is 0, minus 1, which also will come to -3 divided by -1, or 3, the same way. And now that you have a slope, you can use either of these points to find this. So you can have, if we use this 1, 0, we can have y minus y1, which is 0, equals 3 times 20x minus 1. So we're going to, and then sometimes you'll see this distributed, so you can, this is very easy to solve for y. So we'll have y equals 3x minus 3. So point slope form, slope intercept form, and you can see the same thing either way. We could have just easily used this point 0, -3. Okay, next. D. Through 4, 5 and parallel to the x-axis. Now, parallel to the x-axis is what? Let's look at the x-axis. What does the x-axis look like? Well, the x-axis is the line y equals 0. That is the equation of that line. And so in this equation here of the line that we're looking for, m is going to be equal to 0. So if we use slope-intercept form, we'll have y minus y1, which is 5, equals m, well, m is 0, times x minus 4. Well, what we're going to have here is y minus 5 is equal to 0. So y is equal to 5 is going to be our equation of that line. And this line is going to be through 4, 5, which is right here. There's 4, 5, and parallel to the x-axis. That's what that looks like. Okay, next E. We have through 1, 6 and parallel to x plus 2y equals 6. So the easiest thing in the calculus, the one you're going to use the most, is the point slope form. So let's go ahead and look at that quickly. For this, you're going to have, let's find the slope for this. So if we subtract, we're going to take this x over here and we'll make this negative. So we have 2y equals negative x plus 6. So y is equal to negative 1/2 plus 3. Negative 1/2 x plus 3. And so our m is going to be equal to negative 1/2. And accordingly, our line that is through this point and parallel to this line right here is going to be y minus y1 equals m times x minus x1. So that's going to be E. Okay. Yeah, that's going to be right. Okay, next. F. Now we have this thing right here, through -1 comma -2, and this means perpendicular, this little t thing, to 2x plus 5y plus 8 equals 0. So to find the slope of a perpendicular line, we're going to need to find the slope of this line first. Well, if we subtract 2x, we're going to have 5y, and we could subtract 8 also. We're going to have 5y equals -2x minus 8, and we divide by 5, we're going to have y equals -2/5 x minus 8/5. So that's going to be our slope-intercept form. So our m is going to be equal to -2/5. Now, in coordinate geometry, the perpendicular line to this with the slope, this one with the slope of -2/5 is the negative reciprocal. So we'll call our m of our perpendicular line here is going to be 5/2. So this is the slope that we're going to use with the given points. So we're going to have y minus y1, so minus -2 is going to be plus 2 equals 5/2. And we're going to have times quantity x minus -1, so x plus 1. So this is going to be our equation for f. Okay, let's do one more on G. Okay, same type of situation here, except we have perpendicular to x-axis. Well, what does perpendicular to x-axis look like? So here's our x-axis, and we have the point 6, 3, so 1, 2, 3, 4, 5, 6, 3. So here's our point 6, 3 right here. So what does parallel to the x-axis look like? Well, parallel to the x-axis is this looking thing right here. So what this is going to be is you're going to have the x-coordinate on this vertical line is going to be 6. So this is going to be the line x is equal to 6. So that's the equation of the line that is perpendicular or at a right angle to the x-axis. Okay, next, the last thing we're going to look at here is coordinate geometry. Find the slope of the line passing through P and Q. Well, this is similar to what we looked at earlier when we found the equation of a line between 2 points. So our m is going to be equal to y2 minus y1 over x2 minus x1. And so in this instance we have, if we we'll say this q is going to be just arbitrarily x2 comma y2. We're going to have -6 minus 3 over -2 minus -3. And if we simplify this, we're going to get -9 in the numerator. In the denominator, we're going to get -2 minus -3, which is going to be the same as -2 plus 3. So our slope here for this, between these 2 points, is going to be -9. We'll make sure that's right. Yeah, that's right. Okay. Now the last one we're going to look at is coordinate geometry. Show algebraically that the triangle with vertices A, B, and C is isosceles. What we're going to use for this is something called the distance formula. And the distance formula is a version of the Pythagorean theorem, where what you do is you take the square root of, for between 2 points, we'll say x2 minus x1 squared plus y2 minus y1 squared. And we take the square root of that and we will get a distance. And so what we're going to do for the distance opposite angle C, we are going to have the distance between points A and B, because C is that angle opposite the line segment AB. So D of C is going to be equal to, we're going to take these points A and B. So we're going to say -3 minus 0 squared plus, we're going to have -1 minus 2 squared. And for this, you're going to get this -3 squared is going to be 9. And then we have plus 3 squared. That's going to be 9 also. So we're going to get square root of 18. Now you can also write this as take out the 3. If we take 9 as 3 squared, so we can rewrite this as 3 square root of 2, should we so desire. But I think this square root of 18 is going to be enough to work with. Okay, next, so that's one of the sides. Now we're going to take D of A, and so for D of A, we look at points B and C. Okay, so we're going to take -4, which is x2 minus x1, so -4 minus -3 squared plus, we're going to have 3 minus -1 squared. And for that, we're going to have -4 minus -3. That's going to be -1 squared, or 1, plus 3 minus -1 is 4, and 4 squared is 16. So we're going to get the square root of 17. So that's going to be the distance between points B and C. Now one more side we need to get is D of B, and D of B is going to be involved with the points from A to C. So we're going to take this C, which is -4, minus 0 squared plus, and we're going to take 3 minus 2 squared, which is going to be equal to, this -4 squared is going to be 16, so we're going to get 16 plus 1, which also is square root of 17. So what do we have here for sides? We have square root of 18, square root of 17, and square root of 17. And so we conclude, since DA equals DB, two sides are equal, so we have an isosceles. Anyway, that's it. I hope this has been helpful to you. Good luck, and as always, thanks for viewing.